Hi, y'all. My name is Sean Shriver, and I'm a DynamoDB Solutions Architect. I'm here to talk to you about what's new in DynamoDB this year to prepare you for the time when you put these features into use. I've been working on DynamoDB for about 5 years. DynamoDB has some exciting new releases in AWS CloudFormation support, new security improvements with support for CloudTrail data plane logs, and new feature enhancements such as CloudFormation support inside of the Nosql Workbench. But enough about that. We're going to have a chance to dig into those through the course of this presentation. Now, I'll tell you a little bit about myself, so I'm not just some name and face you've seen for the first time. So my name is Sean once again, and I've helped customers all around the United States launch their services on DynamoDB. I've worked with unicorn-sized startups, video streaming services, social media companies, enterprises, and game studios in my role. My job is to make customers successful, and that's the background that I took into making this presentation. I hope you learn how some of these features work so that you can use them immediately and take away the information that helps you whenever you get back into your offices, whether that's in person or remote. Before we begin, let's take a look at our agenda. So we're going to talk about why customers use DynamoDB. DynamoDB is a service that was originally launched in 2012. It's evolved since then to include global secondary indexes for additional ways to query your data, global tables for global replication, ACID transaction support, and more. It has a couple capacity modes like on-demand and provision, depending on how you want to pay for the service. While adding all these features, DynamoDB maintains single-digit millisecond latency and performance, where we've shown that even as request rates increase, the latency decreases. So we'll just make sure you know a little bit more about DynamoDB. After that's done, we're going to talk about the important releases from last year. What's like the top 3 things that we think you should know about? Finally, we'll get into the main course for this presentation, which is a discussion of the releases for 2021. And we'll also include a demo that's kind of centered around CloudFormation and a Nosql Workbench using a data model representing a flight tracking and plane tracking database for an airline. Now, I want to say that this is a 200 level discussion, so we're going to assume that you have some experience with DynamoDB or your company uses it. One thing that we've noticed, especially since I've been in this role for 5 years, is that when we talk with customers today, a lot of them have already used DynamoDB. They've read Alex DeBrie's book on DynamoDB, and they've certainly, most of them, watched the presentation from Rick Houlihan on advanced design patterns from reInvent, which is a seminal talk on all the patterns you need to know, although you should probably listen to it at half speed. So we're kind of targeting people who are familiar with DynamoDB, but that being said, we're going to kind of touch on the benefits first, just so everyone's like level set. Here's what DynamoDB is. So did you know that almost everyone in this session has used DynamoDB in the last month? Indirectly, probably. Many of you have probably even used DynamoDB today to order some coffee, maybe from Uber Eats, restock your kitchen, or stream a show from your favorite streaming service. So can you think of any service that you've used, device you bought, or TV that you turned on that might run on or use DynamoDB? That's a real question. I mean, maybe you can think of it. If you can't think of it and you're not aware of some of our use cases, I'm going to ask you a couple of questions. If you can say yes to any of these things, you've probably used DynamoDB. So in the last 6 months, have you ordered a Lyft? Maybe, maybe not. Have you ordered any food on Uber Eats? I know I have just this week. Have you used a Samsung product in the last week? Say, turned on your smart TV? Or maybe you've made an order on Amazon using a credit card. The credit card information is stored on DynamoDB in an encrypted format. So that should have actually gotten a lot of you to raise your digital hand. You can let us know in the chat how you're using DynamoDB. Many of you have. Now, if you have either launched, if you haven't said yes to any of those, maybe you've done one of these last things. Maybe you launched an EC2 instance, watched a show on Disney Plus, or traveled on an airplane in the last year. And if so, you can say yes to any of that. You've used DynamoDB. The last one about the airplane is based on GE Aviation. I know a lot of people aren't traveling these days, but GE Aviation manufactures, sells, and support engines and planes such as the 747-800 series. And the streaming data about the engine performance makes its way back into a DynamoDB table. An interesting fact is that in commercial planes, GE Aviation has 2 out of 3 of the engines. It's really cool. So why do customers use DynamoDB? It's a very scalable service. We've had single tables hit millions of requests per second. On Prime Day in 2020, we peaked at more than 80 million requests per second. And that's just for Amazon internal and AWS. That's not including all the external customers that continue to use DynamoDB, such as Disney Plus, Snapchat, Netflix, and Lyft. Now, while most of our tables are small, let's say under about 10 gigabytes, we have all those customers that I mentioned before that still rely on DynamoDB. So you can start small and then grow with this over time. Something that's great about Dynamo is you have no pagers, no instance qualification tests, no slow query log. The service just works, and you can use it with either provision mode or pay-as-you-go pricing. It's fully integrated with IAM and CloudTrail. So your credentials from IAM are used to access your DynamoDB table. And then with data plane logging enabled in CloudTrail, which is a new feature for this year, you can see which items were modified when, by what users, from what IP address, using what SDK version. And for more about those details, we will wait a little bit and I'll show you some of the CloudTrail data logs that we publish. And not to mention, DynamoDB is in a single region, in multiple availability zones, and is available as a global version with global tables where we replicate your data all around the world in one click. So in summary, DynamoDB, fully managed, single-digit millisecond latency service, really awesome, depended on by a lot of popular companies that you use in your everyday. So let's get started with a discussion of major releases from the last year. These are a few key things that we think you want to know before we hop into what's new for 2021. The first thing I want to call attention to is support for AWS Glue Elastic Views, where DynamoDB is a source to feed into AWS Glue Elastic View. Elastic Views allows you to create a materialized view in seconds. You create a mapping from a DynamoDB table to a format that AWS Elastic Views supports. And then AWS Elastic View has a set of targets, including Redshift, Amazon S3, and Amazon Elasticsearch, where it will stream the data in a matter of seconds. It's available in private preview today, and this saves a lot of customer effort because in the past you had to use an AWS Lambda function attached to a DynamoDB table along with the DynamoDB stream service, and then you had to manage the process, usually along with like Kinesis data, Firehose. So this saves you a lot of time. Last year, we also released export to S3. It's a native export feature for DynamoDB. It allows you to export data in either DynamoDB JSON or Amazon IN format. Customers use this to improve their disaster recovery strategy with off-region backups in either the same or another external AWS account. You can also use cross-region replication to copy the data into a remote region, and then the export feature will export data into a remote region by default. So some customers have used that feature by creating an AWS Event Bridge rule, a scheduled rule that runs, say, once a week or every night. And then that would invoke a Lambda function, and you write the code in Lambda function to call the backup or the export to S3 API, and it's going to dump the table contents in S3. It's really amazing. And I had a 2 terabyte table and exported it in less than 10 minutes. The last feature I want to mention is the Amazon Kinesis data streams for Amazon DynamoDB integration. So the way this, we'll get into it. I don't want to tell you how it works. We'll get there. DynamoDB is the publisher of records into the stream, and it gives you the full ecosystem of KDS. You can have enhanced fan-out, Kinesis data analytics for streaming SQL queries, or Kinesis data Firehose to take the data from the stream, from the Kinesis data stream, which is full of data from DynamoDB, take that data, put into Firehose, and then put that into Redshift or into S3. So one thing to note is there is an additional cost for using all of these services, so do check out the pricing pages for each of them. Now, let's talk about what's come out this year. Now, this is going to look like there's a lot here. It may not be easy to digest, so I have broken it up into three distinct categories for releases. There's CloudFormation support, new features for existing products, and security enhancements. The real takeaway here is that for DynamoDB, our rate of feature releases is increasing, and it makes DynamoDB a really attractive offering, especially if you're already running on AWS today. First, let's talk about CloudFormation. Now, we offered CloudFormation support for CloudWatch Contributor Insights for DynamoDB, Kinesis data streams for DynamoDB, and for the long-awaited feature for DynamoDB global tables. So often we have customers ask us whether they have hotkeys, and that's where CloudWatch Contributor Insights, also known as CCI, comes into play. I was on the phone today with a customer who was seeing some throttling, and they asked me, "Hey, Sean, is that a hotkey? Do I have a hotkey?" I said, "Well, based on my experience of multiple 5 years doing this, no, it's not a hotkey. It's just randomly bouncing around in your partitions." But then I told them, if you really want to know whether you have a hotkey, you just enable Contributor Insights. You can enable it in the console, minimal cost per event that goes into it, and it'll tell you in a key frequency graph exactly how many keys are throttled and how many keys are accessed per second that are not throttled. It's a great feature. We have some screenshots later on, and we'll get into it. We also have Kinesis data streams. And so Kinesis data streams support inside of Dynamo was great because it answered the question or the feature request of longer retention times for data in DynamoDB streams. Dynamo streams normally has a 24-hour retention time. And with KDS, you can go for a week or I think even more. Last thing, but not the least by any means, is the long-awaited CloudFormation support for global tables, which was released in May. Now, global tables came out in 2017, and we only gained CloudFormation support this year, so that's about 3.5 years in the making. So our customers are super excited, and for our demo today, we're going to dig into how that feature works. Now, there's a couple of features that were added for existing products. So that's kind of like the DynamoDB T3 instance type or DynamoDB Accelerator or DAX T3 instance family support. And then also the Nosql Workbench support for CloudFormation. So DAX supports these T3 instance types. These have variable levels of compute. It's actually a balance of compute, network, memory resources. And it's ideal for workloads where you have a moderate CPU usage that may experience temporary spikes in use. DAX nodes are really known for being constrained by writes. So if you have a surge of writes that come in, it'll kind of burn through the CPU. So with this instance type, you get unlimited credits by default, which are enabled by default on this T3 instance type and DynamoDB Accelerator to give you the extra compute power to process them, process any items that may come in. So that's kind of what you can expect with the T3 instance type. And the Nosql Workbench, we're going to come back to that in a little bit in our demo. Now, there's two exciting security releases. This is kind of CloudTrail support for DynamoDB and CloudTrail support, data plane support for DynamoDB streams. So you may have said, oh, wait, no, I thought DynamoDB was, of course, supported by CloudTrail. Well, the answer is that before these releases, DynamoDB control plane operations were logged into CloudTrail trails in your S3 bucket. So that means any API operation to create a table, describe table, update table, all of those made their way into Dynamo. But we had customers who wanted more details about, hey, when was this credential used to access my Dynamo table? And that's where these features come into play. So if you do enable them, you're really going to enjoy them. And it gives you a lot of data, and the security teams will enjoy them. There is a caveat, which we'll get into, on cost, because just like everything at Dynamo, it is pay-as-you-go. And Dynamo has a really high request rate. The more requests that come into the service, the more data event logs that are created. And it can add up, but we'll get into that. So all of these features that we reviewed, and we're going to keep talking about them. This is just the introduction. We got more details. Have been released on AWS with no need to upgrade your SDKs. There's no patches that you had to apply or maintenance windows. Even if you had the Dynamo SDK that I think was from 2011, you could still interact with DynamoDB. Now you wouldn't know about the new APIs, but you could still put item and get item and all that, which is pretty amazing. And so as you may have seen if you're following DynamoDB, which in case that needs to be clarified, you can go to Twitter/DynamoDB, twitter.com/DynamoDB and follow us. There's a fast accelerated pipeline of releases that are coming out of the service. So it's getting that flywheel of innovation going, as AWS likes to talk about. So yeah, this is exciting. Now we have NoSQL Workbench, and this is where we're going to begin our first demo. So if you're not familiar with NoSQL Workbench, it's a cross-platform client GUI application for database development. It can be used by software engineers, database architects, really anyone who's trying to figure out how to store data in DynamoDB. It has three primary panes: data modeling, data visualization, and the operation building. Data modeling is kind of where you get started. You make your data models, you kind of choose what the attributes are, what the indexes are. Then we get into data visualization, or the visualizer, as you see there. That's where you can create kind of mock data inside of the NoSQL Workbench model. And then you can kind of figure out what are my access patterns, the query patterns that I'm going to use. And then the last one is operation builder, where we take the data that you've created and the keys and indexes that you defined, and we forward engineer them into a DynamoDB table. So that's where we interact with a real DynamoDB table, or DynamoDB local if you want to stay local on your computer and save some money. But a real DynamoDB table, and then you can write your queries, get the Python snippets of code out, and then go run with them, or put them in a run book or a documentation page for the developers to say, you know, when you're querying this flight schedules table, here's how you're going to get it out. You're going to go to, you know, this wiki. You're going to look at this Python snippet. This will get you the data back that you need. So what we announced recently is support for CloudFormation import and export on the NoSQL Workbench. So for this brief demo, what we're going to do is open up the NoSQL Workbench. I'm going to show you the model for the flights and planes. And then I'm going to export the model in CloudFormation format, and then create a CloudFormation stack with it. So we're gonna start with NoSQL Workbench. We're gonna end with a CloudFormation stack with a, I should say, regional DynamoDB table. Later, we're gonna actually make that. We're actually gonna make that a global DynamoDB table. So let's get started. All right, so as I said earlier, DynamoDB has three sections. NoSQL Workbench runs on DynamoDB has three different sections: the data modeler, the visualizer, and the operation builder. So the data modeler is our preferred kind of starting section. I know this is sometimes hard to read, so let me see if I can increase this in size. Okay, looks like I can just do these buttons. Okay, so what we have is a DynamoDB table called Schedule C. I know that's kind of hard to read, and it's following the single table design with a generic partition and sort key name. We've created two GSIs called GSI1 and GSI2. I went ahead and loaded some data. It's not important to understand really all the queries for this, because we're just using this as an example table. It's something quick we can pull off the shelf. But essentially, we're storing information about planes using tail numbers. And we're also storing information about lines, which planes are a part of, using dates. And then we also want to be able to figure out which dates apply to each station, and a station's like a code. I feel like this is all really confusing. I debated whether to even explain it. I figured, just in case you wanted to know, this is just flights. That part's not exactly important. Now, what is important is what this brand new feature does. So once you have modeled your design, you've created the indexes, you've decided, hey, what are my keys going to be? The new feature is that you can edit the model and then go into the capacity settings and modify them. You can choose what my read capacity is going to be, my write capacity is going to be, and that's going to come into play whenever we export this table into CloudFormation. So let's say we are going to say our minimum capacity for this table is 20. Our maximum capacity is 100. units, and then the utilization is 70%. Now, if you don't know what these three things are, this is for application auto-scaling. Application auto-scaling has a target tracking policy which allows the service to scale DynamoDB tables based on request rates, how much capacity is consumed. So if you ever go to the DynamoDB Management Console and enable auto-scaling, it's actually application auto-scaling that it's updating. And these settings here are application auto-scaling settings. Now, you want to enable these whenever you use a provision table. In fact, for Global Tables version 2, the Global Tables 2019 release, you have to enable global tables. So, we want to make sure you have to enable auto-scaling. So we're always going to have it on. So we verified that when we edit the table and look at the indexes and the table capacity, that everything is set. There's auto-scaling settings there. And that's the new feature, one of the new features. The other part of this feature is the export to a CloudFormation JSON. So we're going to export this really quick. And then I'm going to open it up. And here's what we just generated from the tool. Now, one of the things that is a good start, one of the things I want to point out is that what it generated is a good start. It actually created 292 lines of code. And it is really fast and it's really amazing for what it does, but it has some limitations. So did you know that if you delete a CloudFormation stack, that you're going to be deleting the resource? That means it's going to be deleting the DynamoDB table, unless you have a deletion policy in place. Now, I think that you should have a deletion policy of retain in place on not only the DynamoDB table, but all of the auto-scaling settings. So we've got, these application auto-scaling scalable target things. You don't even have to know what that means, but I can just tell you that you're going to want to have it set up so that every single resource in this CloudFormation template is going to be retained when it's deleted, just in case you accidentally delete it. Or in our case, we're going to delete this because we're simulating a migration to an actual DynamoDB global table resource, but we'll get there in a moment. So anyways, give me a moment here. I'm just going to go ahead and add this retain statement to all these policies. Should just take a couple of seconds. Then we're going to upload this to S3. And then once it's in S3, we're going to launch the CloudFormation stack. And now I got that shown up. So find all and bring this down here. There we go. So I should have about 14 of these retain statements, or 15 or so. And the last thing is you should always do whenever you are modifying any kind of policy or a CloudFormation template, you should always use something like cfn-lent, and we're just going to run it and verify that we get no errors back. And we're looking at all these. These are all warnings, and that's great. So we are okay to go. So we're going to go to the CloudFormation console, and we are going to create a new CloudFormation stack. And we are going to use, there's my pre-signed URL. There it is. Okay, so here we go. We've got the CloudFormation template. We're going to upload it now to S3. There we go. And doing that in another window. Then we're going to click next. I'm going to go and drag this up so we can see it. I'm going to give this a stack name. And next. And go ahead and create stack. Now, it is one of the most ambitious things that I can think of to create a CloudFormation stack in a demo, especially if it's done live. So you never really know how long CloudFormation stacks are going to take to complete. There can be weird errors. You can misname a resource. So hopefully this goes well. We shall see. So behind the scenes, this is going to create a DynamoDB table and a bunch of application auto-scaling specific resources. Really what we care about is the DynamoDB table, which is going to be called Schedule C. That's funny. It actually sounds like a tax form. Is that like it might actually be a tax form. So we've done past iterations of this, so you can actually see that there's schedule regular and schedule B and schedule C. But yeah, so we have the table here, and that looks good. It looks like it's create complete and stacks create complete. So we created the DynamoDB table, and the problem with this is that it always starts this way. We create a Dynamo table, but global tables comes out, and maybe you want to create this into a global table. And before this newest release, which we'll kind of talk about in a minute, we didn't have support for global tables in CloudFormation. So if you were to go, say, to global tables and do what I'm going to do, create a replica, you'd actually kind of diverge your CloudFormation stack from the Dynamo resource, and that can create problems later on. So we're going to go and create a replica in US East 1. That is how easy it is to use a CloudFormation. It's or global tables. It is that quick. Once this is done, we're going to come back to it, and we're going to see how do we migrate from this kind of old DynamoDB table resource to the brand new resource, which is called an AWS DynamoDB Global Table, because these are in fact two different things, and this is a problem I think a lot of customers are going to face. They're going to be facing and want some help with. So let's talk more about this kind of new resource and how is this going to help us? Well, instead of having to create a 300-line template with all the application autoscaling settings, with the new global tables resource, it's going to manage and create all of those scaling policies for you automatically. Application autoscaling is always needed for the provision tables. And by the way, it's a common mistake. The customers think on-demand tables need autoscaling. They don't. DynamoDB on-demand pricing model tables don't use autoscaling, so you won't see any of these application autoscaling resources. So it saves you a lot of time, a lot of work looking at that JSON. It's much smaller and tighter for these DynamoDB global table resources. One of the things that is clear at this point is that if you're going to use the CloudFormation support for DynamoDB global tables, you have to create a new resource. We didn't really find a way to reuse the old one, so we had to make a new one. It's not like a V2 like some other resources in CloudFormation. Instead, it's just a separate one. More or less, every single thing that you can do in a regional DynamoDB table is captured inside of the new AWS DynamoDB global table. I'm not seeing any differences that are any missing features, I should say, like CloudWatch contributor insights, for example. One last thing that's really cool about this new feature is that it allows you to launch in a single region, and then it will create the global tables for you in the remote regions. So one stack to create an entire global table and to manage it. I think that's really awesome. So we are going to review kind of what we've done. And I probably should have put the slide in the beginning, but oops. This is kind of what we've done, and this is what we're going to do next. So we've already created this regional DynamoDB table with the AWS DynamoDB table resource. And then we converted the regional table to a global table. That's what's happening underneath. Now, what we want to do is get that managed in a CloudFormation stack with a new resource. And so for that, we're actually going to use a feature of CloudFormation that allows you to import an an existing resource into a CloudFormation stack. Well, if we're lucky, this is updated, but let's go ahead and see. Sometimes I notice that this is the version 2 of the AWS Management Console for DynamoDB, by the way. So if this is new to you, that would totally make sense. But sometimes I notice that this is a little slow in updating, so you may have to do like a full refresh. But eventually, this is going to go into active, and the table is going to be running, and that's going to be really exciting. Now, as soon as that does go to active, in fact, well, let me put it this way. I don't think we even have to wait for it to go active, because the next step which we have to do, and I'm just going to pop this up again, is we need to update the stack. Well, we already did that. We need to delete the AWS DynamoDB table CloudFormation stack. And so we can just delete it. And because CloudFormation is only aware of like a DynamoDB table in that region, and because we verified, and we'll just double verify it, that in here, we only have resources that have deletion policy retained. Then we can just go ahead and delete the stack, and the table will continue to exist. Oh, I just realized that I did it. I called that Schedule D. The other one's called Schedule C. Oops. It's actually the table's actually called Schedule C, even though I called the CloudFormation stack something different. But that's okay, because we're going to delete it, and it's going to be gone no more. So we're relying on the retain policy to ensure the table is kept safe. And just like that, the stack schedule D is gone. My mistake is gone. And so this is to simulate how do you migrate a resource from out of a table and then put it back into out of a stack and put it back into another CloudFormation stack. And so I find it's simpler to just delete the table or delete the stack than it would be to update a template to remove the resources, then add the resource back in as an import. This just seemed easier. But you could either import it into an existing stack or like I'm doing, you can just kind of create a brand new CloudFormation stack and import it. So anyways, let's see. Global tables replica still creating. That's okay. So the replica is still creating, so it says, but the thing about CloudFormation is whenever you launch these stacks, there's a bit of a race to see who updates what resource first. So we might be able to get away with this. One fact we're going to do is go ahead and create a brand new stack, and we're going to use the existing resources option, which imports resources. Now, the CloudFormation template that we're going to use is a basic one that is based on the one that was generated by DynamoDB, by the Nosql Workbench. Now, essentially, I took all these resources over here, and then for time, I copied them over here in every place they needed to be. We'll show you a little bit later some JSON, I guess, for the DynamoDB resource. I don't think JSON's that attractive for demos. I don't really want to, spend too much time pointing at things because it just ended up looking like a kind of a blob of code to most people. But yeah, essentially, this is a global table. It matches all the settings of the global table that we just created. So anyways, we're going to get this GT JSON template. Next. And we're going to try to get it to import Schedule C. And if this doesn't work, that's what we get for using these services live. But if it doesn't work, we can just do it again. And I think I can correct my mistake this time and call this a Schedule C CloudFormation stack. So yeah, here's the moment of truth. On this window, on this pane, it's going to check the resource and just do a basic check to see if the stack creation can continue. Now, the resource has to closely match what's in the CloudFormation template. If there's any kind of glaring issue, it's going to show up. But as far as it's saying right now, it's ready to click import. The import resource is ready to run. I'm going to give it one more run. Let's see if this kind of refresh works and see if there's any issues. Yeah, it's still creating, but in fact, we can kind of show it. Let's say we go to the Virginia region into the tables. You can see, Schedule C is not created yet. That's probably going to be a problem because if it doesn't exist, then it's going to not be able to add it into the region. Yeah, a bit of a problem. So let's see. Well, here's what we're going to do. Eventually, this replica is going to create in global tables in the Northern Virginia region. It is just a matter of time as the workflows run. So we're going to come back at the end of our presentation, and we're going to check it on this table. It's kind of like a cooking show. You make the batter, get all the ingredients together, and then you throw it in the oven, and then you go to commercial break. So we're going to go to our commercial break now. To be continued. Now, earlier I mentioned some of the benefits of CloudWatch Contributor Insights. So you have customers who say, hey, do I have a hotkey? That's what this feature is going to allow you to find out. It's a really interesting service in the way it works. Whenever you enable CloudWatch Contributor Insights, you can choose to turn it on either the base table or the global secondary index. You get to choose exactly which one. Then at that moment, DynamoDB begins to sample your partition and your sort keys, which are your primary keys for the DynamoDB table, and send them to CloudWatch Contributor Insights. At that point, 4 pre-created or managed rules review the keys and find which ones had the highest request rates, and then which ones had the highest number of throttles, and it breaks it up by both partition keys and partition and sort keys. So this is a big feature because in the past you had to contact AWS support, which means you had to pay for support. Then you had to have a support person which was aware of what was called the DynamoDB heat map. And at the end of the day, heat maps would just have these like blue and red colors and wouldn't tell you what the keys are. but CloudWatch Contributor Insights lets you see exactly the key values that are supported. And so with the release this year, CloudWatch Contributor Insights is available in the CloudFormation resource for DynamoDB. It is a kind of simple flag that you turn on, but we'll show you about what that looks like in the CloudFormation template in a little bit. DynamoDB last year also announced a KDS integration, and I don't want to assume everyone understands how it works, but essentially with this feature, DynamoDB is a publisher or producer on the Kinesis data stream that you provide. We take the records from your DynamoDB table, and in a couple of seconds, we push those into the Kinesis data stream. The Kinesis data stream is sharded just like the DynamoDB table, but it is up to you, the customer, to make sure that that has enough shards using the sharding APIs of Kinesis. The great feature of Kinesis data streams is the ecosystem. Kinesis data streams can send data over to Kinesis Data Analytics for those live like Windows SQL queries, to Kinesis Data Firehose to get the data into Redshift or S3 or Elasticsearch, to mention a couple of options. You can also use AWS Lambda functions tied to it, tied to the Kinesis data stream, or something like Amazon EMR using some connectors, like you could write an application with Spark to just pull everything off of the stream. And for that matter, EMR and Hadoop have a huge ecosystem, so there's many different third parties that already have integrations to stream data or pull data off the Kinesis data stream. So that's a really cool feature, and now with one line of code, you can add that to your DynamoDB table. And so here's how it looks. So to add CloudWatch Contributor Insights for DynamoDB, you just include what's called it's really small there, but it's Contributor Insight specification. And to include your Kinesis data stream specification, it's just called Kinesis stream specification. So for CCI, you just set it to enabled and it's turned on. If you have GSIs, you have to go down to the GSI resource and then add the enabled flag. For Kinesis data streams, you can only provide one stream ARN, so you need to make sure that you have that stream prepared, that it has enough shards to match your DynamoDB table. Now, in the AWS documentation for DynamoDB on this feature, there is a kind of formula to help you figure out about how many shards you need to have. Essentially, for every 1,000 WCUs on the DynamoDB table, I believe you need to have one stream shard for Kinesis. Check our documentation, should have the formula for you. You want to make sure that you match the DynamoDB table size to the Kinesis data stream stream size, because or you want to match the DynamoDB table write throughput, I should say, to the Kinesis data stream shard count, so that you're not trying to write to Dynamo 10,000 WCUs, but then you only have one shard on Kinesis data streams, which would only let you do 1,000 WCUs. So you need to make sure those are in sync. Now, I want to mention something important to know for the KDS integration for Amazon DynamoDB. With this feature, DynamoDB does not maintain ordering inside the same item key, not strictly. The reason is that when DynamoDB works as the publisher to put records from the DynamoDB replication logs into the Kinesis data stream service, it uses the put records API. And the put records API doesn't maintain ordering inside of the batch, inside of the actual API operation put records. So for that reason, we suggest you use the approximate creation date time, which is an attribute created by DynamoDB in the storage node layer, as the attribute to order the items inside a collection, which is to say inside items that have the same partition key, or just across all items if you're trying to create just a point-in-time snapshot. Approximate creation date time is accurate to the milliseconds, and it's a pretty good attribute. I should say it's tightly controlled, and the time on that is tightly controlled and synced and alarmed and everything, because that timestamp is used for a lot of different things inside of Dynamo. So CloudTrail has support for data plane activities for Amazon DynamoDB. So CloudTrail data plane logging used to be was a new feature that was announced a couple years back for only Amazon S3, and then DynamoDB wanted to use it, and CloudTrail realized how much volume and how many API calls DynamoDB has, and they had to go re-architect their service to find how do we handle the scale of a DynamoDB table. Once they got it ready to go, we were finally able to release it to you. So this is a feature that's been tested and we know how it scales, and it's a really exciting feature to use. At least for me, because like I like to know where my data is being accessed. I'd say if you're used to a relational database where you can add access logs and you can see every row that's being touched by any user at one time, it can be a bit unnerving. Like, why would I use a NoSQL database if I couldn't tell, when an employee accessed an item, in this example, from an inbox belonging to a famous end user? You'd want to be able to answer that question. Also, like, which AWS SDK versions are we using in our production tables? Or when did we modify the email attribute for a specific end user? All these questions and more can be answered using the CloudTrail logs. Now, important thing to note is that these data plane logs are billed in US East 1 at 10 cents per 100,000 events. I did a little bit of math, and if you're using put item API and your items are about 5 kilobytes, then your CloudTrail log will be about the same price as your write capacity units bill, which is to say, for small items, when you're putting them, CloudTrail will actually be more expensive in that CloudTrail bill than DynamoDB. So we've seen this many times, and so there's a feature of CloudTrail that whenever you turn it on, you can choose for data plane, you can choose whether to do read activities or write activities, and then you can choose what the table ARN is, ARN. And so as you see here in this example, we kind of colored these arrows. It's kind of showing you how when you enable it, you can say, okay, I want to turn on for the dev tables. I want the dev trails to go to this particular S3 bucket or a prefix. You can do the same thing with prod. So you want to selectively enable this on your DynamoDB tables to control costs. That is a best practice. Oh, and by the way, this also added support for DynamoDB streams. So yeah. Now, let's talk about the CloudTrail data plane record format. This is for the nerds out there. We have 3 slides on the JSON. So if you're not a fan of JSON, you can tune out, and we'll be back here to check on the demo in a minute and see how it's doing. CloudTrail data plane format. First of all, in these logs that you get from CloudTrail, you're going to be able to see the ARN, which is the caller's identifier. And in this case, it's a root user. That's really not best practice. You should be using an IAM user or a session, which is an assumed role session. This log will also tell you if the user is MFA authenticated. Did they use a multi-factor device to secure those credentials? Now, of course, we're going to tell you what API operation was used on Dynamo. So in this case, it's to get item. It could be get item for DynamoDB streams. It could be get records, which is the data plane operation for DynamoDB streams. And by the way, when you enable data plane logging for DynamoDB, you're going to get Dynamo and Dynamo streams logs in the same trail. So they're collected and put inside the same trail when you put the table in ARN in there. And you're also going to know the source IP. So where did this call come from? The user agent, which is always interesting. You can see what version of Java is being used, which version of the Java SDK is used. You can actually tell if there's a corporate firewall in the way or a proxy. And then you get into some of the really interesting information, the request parameters. So that's like, what are your key condition expressions? What's the key that you're targeting? What's your limit? It tells you a lot about what that person or actor was trying to get out of the DynamoDB table. Now, interestingly, as far as I've seen, there's no response elements log, so like it doesn't give you data in the API calls that I looked at about what was returned. But one thing you do get back is the request ID. That's great for AWS support. AWS support is going to care about the request ID, so they can go ahead and look up the logs. So with that done, we're going to take the risky thing and click refresh and see, oh yeah, Schedule C is active. That is great. So Schedule C is active in the new region, which means we can go ahead and import this. And this is so we saw this. Okay, so I mean, I don't want to mix metaphors here. So we put the cookies in the oven. Now we're just reaching down with our gloves to take the cookies out of the oven. We don't know if we're going to be successful or this is going to blow up, but we'll see. We want to see this say import complete. Okay. And import complete. Awesome. Okay. That's exactly what we wanted. So we have a new CloudFormation resource. It's a new global table where we imported the Schedule C table. So it's now managed by the stack. And that's everything I wanted. That's just great. So let me come here and just fully refresh this management console. So I see the table. It's got a stream enabled. The global table is there. It's managed by CloudFormation. You can see the other replica in Virginia. And it has auto scaling turned on. And so that means that when we deleted the old stack and we set retain policies, that worked. We didn't accidentally delete those resources. So that's fantastic news. Okay, so that is our demo. So kind of in a recap, I think I can pull up our slide here for the recap. I kind of marked some off. We created a regional DynamoDB table. Then we went through the process of converting it to a global table. And we made sure that the policy that we used to create it was marked with retain. And then we removed it from the stack, which is to say we deleted the stack. And then we added it back in as the new DynamoDB global table resource. And so that just simplified a lot of work. Hopefully that's helpful for you. It's such a commonly requested feature. Customers really wanted it, and boom, there you go. There's how it works. So kind of in wrap up, we've covered a lot of launches. We talked about the new instance types coming or already arriving for DynamoDB Accelerator. We talked about CloudTrail logging, support for new CloudFormation resources like Kinesis Data Streams and Cloud Contributed Insights, and then, of course, Dynamo Global Tables. And we kind of showed you a quick demo of the Nosql Workbench where you have the ability to export the model information to a CloudFormation stack. If you want to learn more about what's coming up this year or at reInvent, which has been announced this year, which part of it will be in person and online, why don't you go ahead and follow us on Twitter at DynamoDB. You can check out that. It's a great insight about what's happening in DynamoDB and what is the community working on. And then the other thing that I'd like to plug is the DynamoDB office hours with Rick Houlihan, the senior practice manager who works for DynamoDB. Wednesdays at 9 a.m. Go to that link. It's Amazon DynamoDB office hours.splashthat.com. And you can see him design different models. And yeah, it's a great resource. Anyways, we have time, about 10 minutes or so, to go into questions. Any questions that you have about these features, about DynamoDB, about really anything. And so please go ahead and ask those questions as they come up, or I guess it's too late, but yeah, go ahead and ask them now. And we are going to take a minute right now to go through them, and then we will begin answering them. Thank you so much for your time and for wanting to learn more about DynamoDB this year. And we'll be right back in a couple seconds.